Hello everyone, this is Meenakshi Dilip Birari, working as an assistant professor in chemistry at Maratha Vidyaprasarak Samaj, Nasik. Till now, we have studied the various topics from second unit of industrial chemistry, that is agrochemicals. We know that the chemicals used in agriculture mainly to protect, preserve and to improve crop yields is called as agrochemicals. Agrochemical industry is growing today because of agrochemical research and advanced development. In this unit, we have studied the utilization of chemicals to improve the production of crops both in quality and also in quantity. Products of pesticide industries are used in large scale to control insect, rodent and mollusk, but also they are having serious health problems of humankind. So in earlier lectures we have studied the introduction and scope of agrochemicals, plant growth regulators, pesticide formulation, slow release pesticide formulation, industrial entomology and also advantages and disadvantages of agrochemicals in detail. In previous lecture, we have studied the synthesis and applications of one of the agrochemical, that is DDT, in detail. Now in today's lecture, we have to study the synthesis and applications of agrochemical BHC, that is benzene hexachloride. We have to study the synthesis and applications of BHC, properties and uses of BHC in detail in today's lecture. So let us begin. First of all, what is BHC? BHC, it is called benzene hexachloride or linden, having molecular formula C6H6Cl6. That means 6 carbon atoms, 6 hydrogens and 6 chlorine. So this one is the molecular formula of benzene hexachloride or linden. Now what is the structure of benzene hexachloride? So this one is the structure of benzene hexachloride. 6 chlorine atoms, 6 carbons and 6 hydrogens. So this one is the structure for BHC or linden. Benzene hexachloride, it possesses 5 main geometrical isomers. The percent of each isomer in commercial BHC powder is alpha 55%, beta 5 to 14%, gamma 10 to 13%, delta 6 to 8% and epsilon 3 to 4%. These isomers are separated from mixture or can be separately prepared. When we observe insecticidal property, the insecticidal property is found only due to the presence of gamma isomer, and hence BHC is also called as gamexane. So we should remember insecticidal property is found only due to the presence of gamma isomer, and hence BHC or linden is also called as gamexane. Refined material is containing 99% gamma isomer. Pure BHC, that means 99%, it is called as gamexane or linden. So what is the molecular formula? What is the structure? We should remember C6H6Cl6 molecular formula, and this is the structure. BHC also having the common names like linden and also gamexane, because the insecticidal property is found only due to the presence of gamma isomer. So it is also known as gamexane. Also, the other common name for benzene hexachloride is 666. due to 6 carbon atoms, 6 hydrogens and 6 chlorines. It is also called as 666 or 666, that is related for benzene hexachloride. So BHC, linden, gamexane are also 666. These are the common names related to this agrochemical. So we should remember the molecular formula and also the structure for benzene hexachloride. It possesses 5 main geometrical isomers, and these isomers are separated from one another or can be separately prepared. An insecticidal property is found only due to the presence of gamma isomer. So it is also called as gamexane. Now BHC or linden is used to various things. These are to protect crop seeds from insects, to control pests and ticks in forest, on pets and livestock, to control ants and other household pests, to control lice and scabies in humans. So BHC is useful for the various things like to protect the crop seeds from insects, to control ants and other household pests, to control lice and scabies in humans. These are useful. Now we have to study the synthesis of benzene hexachloride. This compound exists in number of stereoisomers. 5 isomers are available for benzene hexachloride. The gamma isomer is highly toxic and it was firstly prepared by Faraday in 1825. It is prepared by the addition of chlorine to benzene under sunlight. The gamma isomer is extracted with toluene, xylene, cyclohexane or glacial acetic acid. So what is the reaction to synthesize gamma isomer or benzene hexachloride? So benzene reacts with 3 chlorine atoms. In the presence of sunlight, there is the formation of benzene hexachloride, that is BHC. It was synthesized in 1825 by Faraday, but its insecticidal property is investigated in 1941. It is prepared by chlorinating benzene between 5 degrees Celsius and 60 degrees Celsius in presence of light. So this one is the synthesis of benzene hexachloride. Benzene reacts with 3 chlorine atoms in presence of sunlight or ultraviolet rays. This one is the addition reaction. In that we will get the product benzene hexachloride, that is BHC, having 6 carbon atoms, 6 hydrogens and 6 chlorine, that is C6H6Cl6. It is also called 1,2,3,4,5,6 hexachlorocyclohexane, or it is called as gamexene or gamma hexachlorocyclohexane. So benzene hexachloride BHC, it is prepared by chlorinating benzene between 5 degrees Celsius and 60 degrees Celsius in presence of sunlight or UV radiation. Chlorine gas is passed into liquid benzene in presence of sunlight so that we can obtain the product BHC. Product is containing the mixture of isomer. 12% of gamma isomer is present in the mixture and it is extracted with organic solvents like xylene, toluene, cyclohexane or glacial acetic acid. By repeated crystallization, we can obtain the pure isomer of benzene hexachloride. So that is nothing but gamma isomer, 99% BHC, pure BHC, can be obtained by repeated crystallization. The percentage of gamma isomer can be increased in the presence of substance such as sulfur, cellurium, tellurium, nitrotoluene, etc. For to maintain the reaction is under homogeneous conditions, the amount of benzene is kept excess. So we should remember that if we kept the amount of benzene in excess, the reaction occurs in homogeneous conditions and the product obtained, that is percentage of gamma isomer, can be increased in the presence of the various substances like sulfur, cellurium, tellurium or nitrotoluene. It is also synthesized by use of gamma radiation or elemental fluorine instead of UV radiation. The synthesis of BHC can be carried out in batch process or in continuous process. When we observe the batch process, the reaction between benzene and chlorine is carried out in lead lined vessel, which is facilitated with cooling arrangement. For UV source, mercury vapor lamp can be used and temperature is maintained in between 15 to 20 degrees Celsius, and also pressure is maintained slightly above atmospheric pressure. So there are the two processes which are useful to form the product by using benzene and chlorine. One is batch process, another one is continuous process. In this process, reaction is carried out in a glass lined pipe chlorinator, in the central tube of which benzene is taken, and two 40-watt fluorescent lamps can be used as a UV source. Also, pressure is kept at atmospheric condition. The temperature for continuous process, it is 40 to 60 degrees Celsius. The chlorination is continued till BHC concentration reaches up to 13 to 14%, and the reaction mixture is concentrated at 85 to 88% till gamma isomer is saturated. All the beta and gamma isomer are crystallized out and the molten mixture is cooled to get BHC containing 25% of gamma isomer. The product is separated and also the filtration is carried out. The filtrate is subjected to steam distillation and the isomer is then extracted by solvent extraction method. So these are the two methods for the synthesis of benzene hexachloride. One is batch process or second one is continuous process. The crude or impure BHC, when we consider, it is not suitable for food crops because of its strong musty odors. So we should remember the synthesis of benzene hexachloride. It was first synthesized in 1825 by Faraday, but its insecticidal property is investigated in 1941. And the simple reaction, it is prepared by chlorinating benzene between 5 degrees Celsius and 60 degrees Celsius in presence of sunlight or UV rays. Chlorine gas is passed into liquid benzene in the presence of sunlight and the product is obtained, which contains the mixture of isomer. The 12% of gamma isomer is present in the mixture. It can be extracted with organic solvents. So this one is the total synthesis of BHC, benzene hexachloride. It is also called as gamexene or gamma hexachlorocyclohexane, having the molecular formula C6H6Cl6. Now what are the properties of benzene hexachloride BHC? Impure benzene hexachloride is not suitable for food crops because of its strong musty odors. Refined material is containing 99% pure and it overcomes the odor. When we consider the 99% pure BHC, it is colorless, odorless, crystalline solid, water insoluble but soluble in organic solvent. So benzene hexachloride, it is a white crystalline solid having melting point 110 degrees Celsius with a smell of resembling phosgene. It causes tainting of food with which it comes in contact. It acts more rapidly than DDT. So refined material is containing 99% pure, so it overcomes the odor and it is colorless, odorless, crystalline solid. When we observe the solubility, it is water insoluble but soluble in organic solvent. It is stable to air, heat, light. It is applied as a dust, emulsion, granules or also as water dispersion. So these are the properties of benzene hexachloride. Now what are the applications of benzene hexachloride? It is a fungicide formerly used as a seed treatment especially on wheat to control the fungal disease. It is also used as a pharmaceutical treatment for lice and scabies. The use of BHC is withdrawn on preservation of food grains, pulses, oilseeds, etc. by Ministry of Agriculture, Government of India. It is also used to control various harmful insect, plant pests and animal parasites. Benzene hexachloride kills or controls insect, grasshoppers and common pests. It is used in the form of dust containing 5 to 10 ingredients. In emulsion is containing 25% of gamma isomer. In granules is containing 6 to 10% of active ingredient. Gamexine is having insecticidal activities comparable to DDT. Insects are not killed by DDT but are killed by gamexine. So we should remember those insects are not killed by DDT, those are killed by gamexine, that is by linden. It is also successfully applied against common disease carrying insects, horticulture, household stock, stored food and agricultural pests. It has widely used as an agricultural pesticide. So these are the applications of agrochemical, that is BHC, benzene hexachloride. So in today's lecture we have studied in detail the synthesis and applications of benzene hexachloride, common name, molecular formula, structure, properties and uses. Also we have studied the synthesis of benzene hexachloride by using batch process and continuous process in detail. So in next lecture we have to study the synthesis and applications of endosulfan, which is also one of the agrochemical used in agriculture. So we will see the next synthesis and application in next lecture. Thank you.